Hi, my name is Scott Hackenbrook. I was hired to help with a problem that he had when he brought 200 pounds of concentrates into Anchorage. This was loaded with lead that he was unable to separate from free gold with normal gravity separation processes, and that was actually quite fortunate because it turns out that the lead itself appears to be holding quite a bit of gold. Um, when they melted it, they created a lead gold alloy and needed to know how to get the gold back, and I actually have experience doing that. This is some of the lead after drying the concentrates out, and it's actually bearing gold itself, aside from some free gold that is mixed in with the concentrates. We tried several different approaches, even mercury separation. That didn't work very well. But about 6 pounds of dried concentrates consistently would yield about 3 ounces of gold with these coarse concentrates, about a half an ounce per pound. What was needed to be done was a precise recipe that is tailored to the material. For flux was made up, and then the concentrate smelted at 2,000 degrees. And if the recipe's right, then the precious metals will report to the lead prill or cone at the bottom of the cone mold, and all the other junk will report to the slag. This is the lead cone at the bottom of the slag, and we call it a prill. This is it cleaned up and being weighed. It was about 1/3 of the weight of the concentrates, and from that we got about 3 ounces of gold. The prill is then cleaned and shaped so that it can go into the oven in what's called a cupel. Those dishes there are cupels. They will absorb the molten and oxidized lead when it's run through a set of precise temperatures, and will leave the precious metals behind. This needs to be done correctly, or else you'll have losses of precious metals to the cupel. There's a large dish to the left holding carbon and graphite to maintain heat and to affect the atmosphere. Some small ones there, and then a small production size one. In the middle of the project, the electric oven broke down, and so we tried a alternate process with a propane oven, but that appeared to be risking some unacceptable losses of precious metals, so that was abandoned, and another oven was ordered, and then work resumed. These cupels were kind of small for the amount of material that we were running, so larger cupels were ordered. This is more of a production size, which would fit in that oven and do a decent amount of lead gold alloy at once. The one on the left is used, it's absorbed the lead. The one on the right is new, to show you the difference. This one just came out of the oven and it's red hot, and the precious metal disc or round is in the bottom there. It hasn't been popped out yet, so it's still glowing. That'll get cleaned up. Typically we were looking at about 40% gold purity, a little more than that in copper, and a small amount of silver. In order to have a nice consistent bit of gold to sell to the buyer, that needed to be refined a little bit more. As you can see in a picture coming up, there were quite a few different pieces of varying purities that needed to be added all together. Some had more copper than others, some had more gold than others. There's a good example right there. That was melted all together with a specific amount of silver to get to a certain ratio, so that the impurities could be removed with a nitric acid leach. Here, they're being a large wedge of the gold alloy is being melted with a specific amount of silver. And then I pulled this video off of the internet showing the molten metal being dropped into water to make a cornflake out of the material, because I couldn't videotape it myself and do it. This is that cornflake from that alloy that you just saw, and then dilute nitric acid is poured over that, and that will dissolve out all of the copper, all of the base metals, and recover the silver and the silver that was naturally present with the gold from the mine. So that silver is actually able to be recovered and paid for. This is where it is before recovery in this silver nitrate solution. And this is the honeycomb of nearly pure gold that is left after the impurities have been leached out with the nitric acid. That gets washed up and cleaned up, and as much impurity taken out of it as possible, which should leave it at about 98% pure. That's very pure right there, and that produces a very nice bar like that 20-ounce bar there. Now, that was from the coarse material. Some of the material was a higher grade with much higher precious metal content. This prill right here shows that it's a much higher precious metal content, as you can see from that light color. The dark color is just leftover slag that hasn't come off of it yet. Here it is being put in the hot cupel before getting put back into the oven. The top's been beat down a little bit, which knocked away that excess slag. And then after cupellation, we had a nice chunk of precious metal, gold and silver, and some copper. That contributed to a nice bar in the end as well. Now, there were some concentrates that were fine. They didn't have as much coarse lead in it, so there wasn't as much gold. This was concentrated on my shaker table so that excess propane wouldn't have to be used to do multiple smelts, because the gold content was actually fairly low per pound. But we did end up getting about an ounce of metal out of all of this in the end. So the shaker table was helpful in concentrating that further than it was able to be done at the mine. This is the precious metal disc that came out of those fines, about an ounce. This was quite a long and challenging project. The material was very difficult to work with, but in the end we were able to recover approximately 62 troy ounces of actual gold at various levels of purity. Now, two of these bars, the one marked 4.34 ounces and the most yellow one, second from the right, are practically pure, and that's from just the nitric acid leach in the inquartation process. All of these could be refined further to the standard of 99.9% purity, 999 purity. But you wouldn't get any additional value from that and selling it to the buyer. They're quite happy to buy it at less purity than that. Bringing it up into the mid to high 90s does, however, assure that you're getting a good, accurate analysis of the gold that you're selling to them. So the nitric acid leach is worth the effort on that score. Some of these are less pure than the others because we were still working out the nitric acid leach for the quantity of gold that we were doing. And by the time we got to the 21 ounce bar there, it was we had it down pat. The 4.3 ounce bar was actually taking that extra step with Aqua Regia and is triple nine, 99.9% pure. Unless you're going to make a retail product such as coins or bars that are sold on the internet at a premium, there's probably not a strong reason that I can think of at this time to go to the Aqua Regia process. Doing the nitric acid leach recovers the silver and brings it to a high purity and consistency. So thank you very much.